Broadcast is now starting. All attendees are in listen-only mode.
Today we'll talk about different scheduler, a present in Hadoop. So let me write the name first. This is the scheduler which is given by Hadoop for you, and this is already set in your Hadoop cluster by your administrator. That how your job is getting submitted, right? So whenever you submit anything, whether they are whether they are sequential computing, parallel computing, that's one thing. And second, which scheduler we are using inside our cluster. Scheduler. Now, first three types of schedulers are there in Hadoop. I'll name them one by one. First is FIFO. It's a quite clear concept. What is FIFO, right? We are seeing this FIFO thing since many programming and many data structure platform. That FIFO stand for first in, first out. Okay, it works with the concept of queue. So we have queue and stake. Stake is by default LIFO, and this is FIFO. Now, second is fair scheduler. Third one is capacity. I'll explain you one by one how FIFO submit, how fair submit, how capacity scheduler submit. So capacity is the best one according to production system, but FIFO and fair is not good for production cluster. This is good for your main system where your live data is coming. I'll tell you why. So let's say you submit. Your task is this. Your task is to submit 6 jobs at a time, or let me say 5 jobs at a time. So submit 5 job in parallel. When I say job, I'm trying to access 5 table maybe from RDBMS to here if I'm doing data extraction, or if my 5 file is present in Hadoop, so I'm processing them. That's what I'm calling a 5 job. These are individual job J1, J2, J3, right? So submit 5 job in parallel in your Hadoop cluster. So this is their dynamics: J1, J2, J3, J4, and J5. So when I'm processing 5 file, please understand what is this 5 job. This 5 job I have written to process. I have written this 5 job to process, let's say 5 file which are present in HDFS. So I have written some logic in MapReduce, and I'm submitting that Hadoop jar name, class name, input, output. That command I'm submitting from client. Okay. Now what will happen? There are total 5 jobs, and let's say your resources. So when I say resources, I mean these two things. Resources. So this resources means CPU and RAM. This two thing is my main resources, which helps me to compute my job and divide them in an individual task. Okay, based on the data size, we know 128 MB will give us one task. So J1 is having a file size of 200 MB. This code is processing 200 MB of file. This is processing 1 GB of file. This is processing, let's say, 10 MB. This file is large enough compared to all. This is somewhere 4 GB. And J5 is 500 MB. Now my question here, okay, or how internally this computation is happening, how my yarn, which is a resource manager and node manager, they will compute how many total CPU RAM should be given to J1, J2, J3 and so on till 5. Okay, so using FIFO, if I'm using the first one, okay, if I'm using the FIFO one, what they do, FIFO will be submitted in a queue one by one. So FIFO will create one queue, FIFO first in first out scheduler will create a queue, and this is the queue, let's say J1, then J2, then J3, then J4, then J5, right? The name itself says first in first out. Whichever job gets submitted first, it will complete first. This is not the parallel computing. FIFO scheduler is a sequential computing. Make sure you know this point. FIFO scheduler is a sequential computing. They work in a sequence. Okay. Though you have 4 CPU or 5 CPU or 100 CPU, doesn't matter. They will submit all your job one by one, not all together. So this is not fulfilling the exact requirement of Hadoop. And second problem, suppose this is my queue created currently. Okay, and this total J1 to J5 is taking me 3 years time to complete the task. Okay, but my business comes and says my priority is now given to J3. I want to complete this job before J2. Okay, I'm saying I want to complete this J3 job before J2. Can I do that? In FIFO, I can't do that because this queue is already created. If I want to change the queue order or priority, I need to cancel the queue and resubmit it again if I'm using the FIFO one. Okay, so in a nutshell, we can say FIFO scheduler is submitting all jobs in a sequence, and they are following one created queue based on the priority of job, which is predefined. Okay, on ad hoc basis or on runtime basis, I cannot define that I want to submit this or I want to submit this. That's what the scheduler is saying. Second scheduler is my fair scheduler, and fair scheduler is terrific, but again failing at some point. Now focus the name here. If you just remember the name, you'll understand the concept. Fair scheduler. Now same thing, I have total job 5, J1, J2, J3, J4 and J5. Okay, now my total available memory, CPU, RAM, those computation resources are 100% available. They're 100% available. And we have seen this job size 200 MB. Let me rewrite again. This is 200 MB. This is 1 GB. This is 10 MB. This is 4 GB. This is 500 MB. This is the size of my jobs, which file they're processing. Now, what fair scheduler says, I will provide equal resources to all the job. Fair scheduler is saying, I will provide, if my 100% memory is available, then I will provide 20%, 20%, 20%. Each job will get 20%, 20% memory. Let's say my total memory and CPU. Okay, my total memory and CPU here is memories, let's say total 8 GB. 8 GB memory is available in the system, in my node. Now, if I take 8 GB of 20%, 8 GB of 20%, this would be how much if I distribute this in 5? So I can divide this by, once again, 1024 GB into 8. And equally, if I want to divide this, I'll say 2 GB will give me 4. So 1.5, 3, 3, okay, 1 point. So roughly it will give me 1.7 GB each job will get. Okay, if my total memory is 8 GB available, RAM is 8 GB available in the cluster, so every job will get 1.7 GB of RAM for the computation. But problem is, don't you think this is not a good computation? Because there my file size is very small. It's a 200 MB. There my file size is comparatively way bigger. This is less than 4 GB but more than 200 MB. This is very small file. This is again a middle file. But if I'm giving equal resources to all, which means this job will complete as soon as possible. This job will complete. So how my job completion will happen here? My J3 will complete first because this is just having a 10 MB of file. After J3, then J1 will complete, then J5 will complete, then J2 will complete, then J4 will complete. This is their completion. This is their completion order. Guys, my question is simple here. If my job size is bigger, I should give more resources to that job. So I should give less to this and highest to this. But this is not happening in fair scheduler. Okay, it says how many job is total submitted in the cluster. I will provide equal resources to all the job. Now, how can I cater the equality? And I don't want to give equal resources. I want to give resources based on the size of the file. This is the third scheduler, which is your capacity scheduler. So up to you. Okay, Hadoop uses by default fair scheduler. Hadoop by default uses this one. But if you want to change it, you can change it from fair to capacity or any other scheduler. Capacity scheduler. Okay, what is the capacity scheduler? So they say we will keep 75% RAM. Okay, we'll keep 75% RAM. I'll call them as a resources. 75 resources for regular jobs. 25% resources for ad hoc jobs. Okay, 25% I'm keeping for my ad hoc thing, and 75% I'm keeping for my regular jobs. This way I'm able to somehow manage. Then this is the best setup, right? Or configuration, because I do not have any problem for my regular job. They can be submitted using this memory space. And ad hoc jobs, if my business is asking me or client is asking me to create, I can submit those things in this 25% memory space. This is what is a scheduler. So you should know the scheduler. You're not setting though how this is working and which scheduler you are using in your system, in your production cluster. Should be clear. Next approach is codec. Next approach is a codec. Codec stands for compression and decompression. Compression and decompression. This is the full form of this codec system. Okay. Now, compression and decompression. Okay, now let's see how many different compression and decompression is available in Hadoop. But first question, always for anything, why we are doing this? Okay, this is a very small question, but this is giving you many insights, because if this is not clear, guys, no need to know. I mean, as in, it will be difficult to understand what is this compression decompression and how this is working. So please maintain the order. Whenever you learn anything, if you do not know, go to Wikipedia, learn about it. What is this? Why you are doing this? What concept this is building for you? Then how party anyways we are doing in the classroom, as in this session. So codec is a compression and decompression. And if I answer you the why part, right? In general, we are using this compression technique in our system also to reduce the size, or spaces, and to reduce the size and space, and increase file transfer, isn't it? This is what we're doing using compression and decompression. My main agenda is this. If you ask me why we are doing this, I'll say reducing the size and increasing or speeding data transfer. Speeding, let me write it, or speeding data transfer. So it's more on the theoretical side, okay? Compression and decompression is. And the easy part, Hadoop has already given all the packages to their developer. We are not writing a hard code to achieve this compression and decompression. Hadoop says, I will provide you the package. Whichever compression and decompression you want to use, you can use them in your cluster to compress the data, obviously. So these are the compression types. 6 different compression Hadoop supports. First compression type is deflat. Second compression type is uh, first is a deflat. Second compression type is snappy. Third compression type is gunzip. This gunzip is very common, right? We are seeing in many file the star.gunzip when we download any file. Then bzip2. This is a new format. Then fifth one is a lzo. Then sixth one is a lz4. This is total 6 different compression technique which Hadoop uses or provided to their community developer, that they can use the 6 different compression technique to store the data in Hadoop cluster. Now next question, which one is a fast in compression and which one is fast in decompression? Because if you say me that I have many techniques available, immediate question, which one is the best here, or which one is a by default? So Hadoop uses Snappy as a by default. And make a note, Hadoop uses this Snappy as a by default codec, by default compression technique. So if I use a Snappy, how do I know that file is having Snappy compression or gunzip compression? Based on the extension. So if I see extension as .snappy, it is a snappy file. If I see extension as a .gunzip, it's a ZZ file. And similarly .lzo, .lz4, .bzip2, .deflat, .snappy. So this information is written in chapter number 5, guys. In chapter 5 of Hadoop Definitive Guide. It's more on the theory. You can there are 2 different pages. One side compression, second side decompression. You can go there in 5 chapter and see this compression and decompression if you want to see the theory. Comparison between all deflat, gunzip, lzo, snappy, bzip2. So I'll leave this for your study. Now, how can I give a flag? How can I give a flag if I want to reduce the size or if I want to speed up the transfer? So there are two different flags to achieve these two things. Suppose I want to achieve more space. I'll say -9 or -9. This is for space. So suppose I have a file, write it here. I have a file. I'll say zz gunzip -9 and file name. This will take a while to submit zz-9 file. And once this is zipped, okay, once this is zipped, if I run this command ls-lrt, what I will see, I will say this file dot gunzip. Okay, that's one. So -9 for space. How about speed? So that is -1. This two parameter we follow, guys. One for speed up, second for space uh, from the cluster or hard disk. So if I show you, let me open a book actually. So I'll make it easy for you. Keep this some part as your as Hadoop book as an assignment, and please go today read this few parts which I'll explain you today. So I'm opening a book, uh, Hadoop related books. Where it's gone? Okay, Hadoop books. Oh, really? Definitely. Directly we'll go to chapter number 5. So in chapter 5, if you see, this is the compression, which has codecs, compression, decompression, and input aspect. You click there, and please see this 5 parts. Okay, let me increase this. Check this 6 different name: the flat, gunzip, bzip2, lzo, lz4, and snappy. So you'll find that somewhere it is written that snappy is a by default compression technique which Hadoop uses. This is the two thing: -1 for speed, -9 for space. Okay. Then this paragraph you can read which one is fast in compression, which one is fast in decompression. And to achieve all this, there are separate packages created. So no need to write a hard code logic. You'll have to add these values in your property, in your configuration file. So once you add these values in your configuration file, automatically it will start sorting your data in this compression form. Okay, so very easy. Only the question can come from this two part: which one you are using and why you are using this. Why you are using the flat, maybe why you are using CZ. You can answer that this is good in compression, this is good in decompression, and I wanted to achieve this first part. After compression and decompression, second thing is a counter. It's a counter. Let's go and see what is a counter and why counter is helping again. So counter are only created counters are only created. You see this all the job file. Practically we'll do when we learn Scala. Okay, don't worry. Counters are only created when job gets successfully completed. Let's read it again. Counters are only created when job gets successfully completed. So if job is failed in between while processing, okay, so counter will not be generated. If it is failing in between, counter will not be generated, and there are 6 different types of counter. Actually, 7 different types of counter. Let me name them. Job counter, task counter, okay, and this counter is giving me this informations: how many bytes in, bytes out, bytes in, bytes out, then network in, network out, memory in, memory out. In and out means when you're communicating from one cluster to another cluster, right? There is a two-way communication. One is a request, second is acknowledgement. So when I'm writing something, I say that is in. When I'm giving acknowledgement, I say that is out. This is why every time it has two acknowledgement, one in, one out. So job counter, task counter, user defined Java counter, user defined Java counter, dynamic counter, retrieving counter, file system input counter, and file system output counter. File system input counter and file system output counter. Now the question is, counters are created, but again, uh, after their successfully completion, also what we're trying to detect here as a detective. So we're trying to detect few things. We are using our diagnosis mechanism. We are using our troubleshoot. So we are troubleshooting the jobs. Whatever jobs we're submitting, we're troubleshooting and we're diagnosing it. So suppose today I'm submitting one job, J1, okay, and J1 file is taking uh, total complete to this job. What is the completion time? So this completion time is 25 minutes using some resources that I will definitely check in my counters. So basically this counters is providing me log information in form of this bytes in, bytes out, memory in, memory out, network in, network out. So job one is taking, what is the today's date? It is, I believe, 27th April. One second. Yeah. So this is taking total time 25 minutes to complete this, and I'm submitting this job on 27th April. Now, this is a daily job. If I want to submit the same job tomorrow with definitely different data type, because when I say daily, which means this job is submitting in every business days. So if there is a 1 month from first date to 30th date, you'll see there are 22 business days roughly on average. So 22 दिन होता है month में. Okay, that's what I'm calling as a business days. तो J1 ने आज लिया टाइम 25 मिनट. अब ये J2 J1 when I'm submitting tomorrow, when I'm submitting this J1 tomorrow, which is 28th April, क्योंकि ये तो सबमिट रोज करना है. लेट्स से दिस इज रिलेटेड टू बैंकिंग. तो बैंक में आज 10 कस्टमर आए, कल 40 कस्टमर आए, 29 अप्रैल को 100 कस्टमर आए, ऐसा करके दिस इंफॉर्मेशन ऐसा करके दिस इंफॉर्मेशन is getting every day different. So J1 is taking this time to complete the task is 35 minutes. Okay. Now you see that there is a 10-minute difference in J1. Now you will check, you'll diagnose and troubleshoot your jobs using counter. Two things. What was data earlier to process on 27th April? यहाँ पे डेटा का साइज कितना था? Okay. So since this looks little difficult, I'm talking in Hindi so that things is very clear to you guys. Okay. What I'm saying here, यहाँ पे जो फाइल का साइज था डेली बेसिस पे वो कितना था डेटा, एंड अवेलेबल सीपीयू कितने थे कंप्यूटेशन के लिए. So what was the available CPU for the computation in 27th April? Now same thing I will check here also. What is the total data size in 28th April, and what is the CPU available on the same date? If I just check this two things, I can get to know that why this is taking extra 10 minutes compared to this. So let me say this is J1 dash. This is J1, this is J1 dash. Okay. So counters are helpful at times to encounter the problem. This is guys pretty much MapReduce, and next job is to extract the data. So here we completed our MapReduce part, which is the most complex section in Hadoop, I'll say, where though we're not writing today a programming, but whatever session we have taken for MapReduce, I think last week all 5 days and today is purely based on this. Now my next job after MapReduce, when I get the data, then only I will analyze it, right? If data itself is not present, how can I analyze it? Now this is my real-time analysis. So your data is flowing from upstream source. Your data is flowing from upstream source to downstream source. I'll tell you what is upstream and downstream. Just bear with me. Downstream source. Okay. So upstream source is nothing but a web server, guys. Upstream source is a web server, and downstream source is your RDBMS, Relational Database Management System, Oracle, MySQL. Okay, I have asked you guys to practice this also, databases. So we know what is a database now. Now let's take one example. Let's take one example to understand the upstream source and downstream source. So what happened? Again, you visit today a powertech.com. So we'll open the site and say I have some question related to the content and other things, right? So what I'll do, I'll go to some query point. Query section is, I think, not given here. This is an Indian site, powertech.in. And this is for, well, international location, okay? Let's stick to this currently. When I go and when I put a query here, so I'll write my name, I'll write my email address, I will write my contact address, my subject, my message. The moment I submit all this information one by one, right here, just like a filling a template. So this is a website, right? And this website is hosted in some IP address. This website is hosted with some IP address as in 192.168.10.1. and must be having some server location. Server location. So I know the server location. This is Bangalore. They have kept their server in Bangalore. That's okay. But now, whenever you request anything from Pune, your request is going, when you visit to the site, your request is going to Bangalore. And when you're submitting all this information, so where this is getting stored, this information is getting stored in a table of RDBMS in a structured form. In a structured form, this table will be there, and it will have all this information, that what's your name, what's your email, what's your contact detail, what's your subject, and what's your message. So name, here name will be there. Suppose I submit, because this query I can submit it anytime. Let's say I'm practicing it late night, 3 a.m., and I get a question while watching the video. Now when I could get a question, I thought to put a question and ask a help from the support. When I put a question here, submit all this information, so this is going and storing in a table. And likewise this is happening. So suppose if 10 tables are putting 10 people are putting a query, if 10 people are putting their query, all these 10 people entries are getting stored in this table one by one. First this name, second, third, fourth, fifth, sixth. Now which one? This obviously works with the based on queue, that whoever has given a query first, I will solve that first, then second, then third, then fourth, then fifth, then likewise I'll go. Now how can I say parallel processing here? If there are three support people, support 1, support 2, support 3, if there are three support folks, then at a time they can pick three different ticket. They can assign three ticket at the same time and start working together. Once they are done, they'll close their ticket and send you for feedback. This is what happened in general. This is a standard approach. But my question is, this information is getting stored where? Or if you go to Amazon site, or if you go to your net banking site, when you do any transaction in real-time environment, where that data is getting stored, that data is going to your relational database management system. Precisely say this is MySQL or Oracle. I'll use MySQL since my system is having MySQL installed already. Okay. Now, uh, continuously upstream data is storing in downstream source from server. Okay, this is a real-time data, and I want to extract this data first to my Hadoop distributed file system, because we know in Hadoop we are only doing OLAP. We know in Hadoop we are only doing this online analytical processing, right? So if I'm extracting this information right from here, I need some ETL tool, extract, transformation, and load. And this ETL is scoop. This can be Spark SQL. This can be Informatica. There are many ETL tools. Okay, I'm not focusing on the tool name currently. I'm interested to know the logic and the communication from this system to this system, because this is one database. This is also one database which keeps the file, not the table. But how do I do this? I need to create a bridge, right? All the communication will happen with the help of this bridge. Then only you can start doing analysis. So MapReduce will only work when you have some input available in this HDFS. Because if you don't have a data, what MapReduce will process? So whenever you work in any industry, okay, and especially that company is doing historical data analysis, so your job is to extract the data first and store in HDFS using either one Scoop or Spark SQL. That's the first agenda of my real-time activity. Because if there is no data, there is no process. Simple. So first we need a data. First we need an information to be extracted by some tool. Then later we'll see how can this data be analyzed using tools. Okay. So I hope this is clear. RDBMS is getting entry. A scoop will start tomorrow. So our today I'll not start because we have we have few minutes left. Okay. So I'll start this scoop part tomorrow, and we'll see how scoop can extract this information. This is a combination of guys SQL plus Hadoop. This is a combination of SQL plus Hadoop. SQ part is taken from SQL and OOP part is taken from Hadoop, and combined we call scoop. So let's see the scoop strategy tomorrow. Today, please complete all the MapReduce. Again, revise it because I will be using all the fundamentals of MapReduce in scoop, as this is dependent on the execution engine of it. We'll see tomorrow.